Now here the question is, we need to prove that this integral tan inverse ax upon x 1 plus x square dx is equal to pi by 2 log 1 plus a when a is greater than or equal to 0. And we'll also need to find the value of integral if a is less than 0. Now clearly parameter here is a, limits are constant. So this integral will be some function of a. So we'll write this as fa equals this integral. Now if we put a as 0, then here it will be 0. We can say that value of f0 is 0. So we have this initial condition that when the value of a is 0, value of function is also 0. Now we'll differentiate this function. We'll find f dash a and it will be equal to this integral from 0 to infinite. Now Leibniz rule says we have to differentiate this function partially with respect to a. Now we can write this as 1 upon x into 1 plus x square. And then when we differentiate this function, we'll write this as 1 upon 1 plus a square x square into x. Now here x and x will cancel. We'll write this as dx. So this f dash a, it will be this integral from 0 to infinite dx upon 1 plus x square into 1 plus a square x square. Now we can split this integral using partial fractions. So we can write this as f dash a equals this integral from 0 to infinite a upon 1 plus x square plus b upon 1 plus a square x square into dx. Now we have to find the value of a and b. Now for a, we'll put x square as minus 1. Then we'll get this as 1 minus a square. So value of a simply will be 1 upon 1 minus a square. And for b, we'll put x square as minus 1 upon a square. So if we put minus 1 upon a square here, we'll get b as a square upon a square minus 1. So we can add this function f dash a as this integral 1 upon 1 minus a square from 0 to infinite dx upon 1 plus x square and then minus a square upon 1 minus a square 0 to infinite dx upon 1 plus a square x square. Now this is f dash a equals 1 upon 1 minus a square, and this is nothing but tan inverse x from 0 to infinite and then minus a square upon 1 minus a square into it'll be tan inverse ax upon a. Now here a and a will cancel. Now this again is from 0 to infinite. So we'll write this as f dash a equals, now here tan inverse infinite is pi by 2 and tan inverse 0 is 0. So it will be pi by 2 1 minus a square and then here it will be a upon 1 minus a square. This limit x tends to infinite tan inverse ax minus 0. Now what about this limit tan inverse ax? Now this limit, it depends on a. If a is positive, then it will be tan inverse plus infinite, which is pi by 2, and if a is negative, then it will be minus pi by 2. So we have to consider two cases. Case 1, when a is greater than or equal to 0. So if a is greater than or equal to 0, we write f dash a as pi upon 2 into 1 minus a square minus a 1 minus a square into pi by 2. So we'll get this as pi by 2. In the numerator we'll have 1 minus a and in the denominator we'll have 1 minus a square. Now 1 minus a will cancel. So we'll write this as pi upon 2 1 plus a. So this is your f dash a. Now we'll integrate this function with respect to a. So this is nothing but fa, and it'll be pi by 2 log 1 plus a plus c. Now initial condition is when the value of a is 0, value of this function is also 0. So this is 0. Now we'll put a as 0, log 1 is 0, plus c. That means value of c is 0. So value of this integral when a is greater than 0 is simply pi by 2 log 1 plus a. And this is what we need to prove in the first part. Pi by 2 log 1 plus a when a is greater than or equal to 0. Now we'll come to the second part when a is less than 0. Now if a is less than 0, in this case it will be tan inverse minus infinite, which is minus pi by 2. So we can write f dash a as pi by 2 1 minus a square and then minus a upon 1 minus a square into minus pi by 2. Now we can write this as f dash a equals 2 into 1 minus a square, and the numerator will be pi and 1 plus a. Now 1 plus a will cancel, we'll get this as pi upon 2 1 minus a. Now again we'll integrate this function with respect to a. So we'll get this as fa, and it'll be equal to pi by 2 log 1 minus a and then plus c. Now again when a is 0, fx is 0. So it'll be 0, 0 plus c. So value of c here is 0. In that case, we'll get the value of this integral as fa equals pi by 2 log 1 minus a. So value of this integral is pi by 2 log 1 plus a if a is greater than or equal to 0, and it'll be pi by 2 log 1 minus a when a is less than 0. And this is how we prove such questions.